Problem number 23. In the right triangle, the base decreasing by length by 3 centimeters per second. Area is increasing by 15 square centimeters per second. Before we do anything else, we really should be drawing a picture here. So we have here a right triangle. This is the base. This is the height. And what we want to do here is let's relate the area to the base times the height. So area is equal to 1/2 base times the height. And this is a related rates problem. Let's take the derivative of everything here with respect to time. So on the left, we have the derivative of area with respect to time. On the left here. On the right, 1/2 times the derivative of b times h with respect to time. We're going to have to use the product rule here. And that's going to give us 1/2 times the derivative db dt, the derivative of the base with respect to time times h, plus 1/2 times b times the derivative of the height with respect to time. Okay, so we know this is our formula for the area of a triangle here, and then related rates, differentiation gives us this way to relate together dA dt, dB dt, and dH dt. So then the next thing we have to do is realize that we're given information here about 2 of these 3 derivatives. Base going down at 3 centimeters per second, this is telling us that dB dt is equal to -3 centimeters per second. We want to include the units. The area is increasing at 15 centimeters per second. That's telling us that dA dt is equal to +15. So what we can do is plop in dA dt and dB dt, and let's just let us solve for dH dt. Okay, dA dt is 15, and it's equal to 1/2 times -3 times h plus 1/2 b dH dt. All right, 15 is equal to, let me just go ahead and do -3/2 h plus 1/2 b dH dt. Okay, time to go back to the problem, get some more information here. Okay, I see that it says at the time when the base is 15 centimeters and the height is 20 centimeters. Okay, so now we have to plop in 15 and 20 into this. So 15 is equal to -3/2 times h, -3/2 times 20, plus 1/2 times b is 15 dH dt, and now we should have enough information here to solve for dH dt. 15 is equal to -3/2 times 20 is -30, plus 15 over 2 dH dt. Add 30 to both sides here. That's 45 is equal to 15 over 2 dH dt. Multiply, divide by 15 over 2 and multiply by 2 over 15. That looks like 6 is dH dt. Okay, so 6 is dH dt right here, so that answers part A. And part C says, what's the units of our answer in part A? Let's just go ahead and do that right now. So this is going to be 6 centimeters per second. Okay, part B. Part B is asking us for the hypotenuse length. Okay, so how do we find the hypotenuse? Let me go back and say C is our hypotenuse. We should know by Pythagorean theorem that h squared plus b squared is equal to c squared. The sum of the squares of the legs here is equal to the square of the length of the hypotenuse. And okay, doing related rates, taking the derivative with respect to t of everything here, the derivative with respect to t of h squared is 2h dh dt. The derivative with respect to t of b squared is 2b db dt. The derivative with respect to t of c squared is 2c dc dt. There's factors of 2 in every single term here. I'm just going to go ahead and cancel those out. And then dc dt, we're being asked for the rate of the length of the hypotenuse. We divide both sides here by c. We get h times dh dt plus b times db dt. All of that divided by c is dc dt. Okay, so we need to plop in 1, 2, 3, 4, 5 values here, but we have most of them already here. H is 20. dH dt is, we just found that was 6. B is 15. dB dt, we were given that as -3. Is dc dt. The only thing that we haven't yet done is we need c here itself, the length of the hypotenuse. So when at the base is 15 and the height is 20, this is going to be a 3, 4, 5. C is going to be 25. Check that for yourself. So here, this is going to be our final answer. I mean, you can simplify this if you want to, but this is dc dt. To finish off, in part B, is the length of the hypotenuse increasing, decreasing, or staying constant? That's asking us, is this positive or negative? So I guess we do have to simplify this just a little bit. 20 times 6 is 120 minus 45 here. 120 minus 45 is going to be 75 over 25 is 3. And because that's positive, the length of the hypotenuse is increasing there because the derivative is positive.